Hey, what's happening, guys? Today we're going to go all the way back to the super basics of the 555, the NE555P, the triple fiber timer, that little 8-pin chip that we all know and love. First question always, why is it called a timer? It's called a timer because it can output a specific pulse length or pulse time. And this circuit that you see here, there's a 555 timer. There's a switch. There's an LED. Doesn't look like much. But when I move the switch from one side to the other, the LED lights. Yes, I've turned the 555 timer into an on-off switch, but that's not the point of this. The point of this is to understand why I can do that. And by the time you're done with this video, in probably less than 10 minutes, hopefully you're going to understand it too. So, for that, we need to talk about what the individual pins of the 555 do. There are 8 pins. It's an 8-pin package. You can always tell pin 1 by looking for that indentation, or sometimes a dot, or sometimes both. But the 555 is generally, it's usually labeled very well. Along with a bunch of other random words up there. But just in the way it reads, that's your orientation. So, pin 1 of the 555 timer, located directly below the notch or the dot, is our ground pin. Pretty simple. What does the ground pin do? It connects us to 0 volts. That's what it does. Whatever's touching that pin will be connected to 0 volts. Pin 2 is our trigger pin, and it turns the output on when it gets a voltage that is greater than 1/3 VCC, our supply voltage, okay? You can see us up here on pin number 8. Next up, pin 3. That would be 3, that would be 2, Paul. 3. That is our output pin. What does it do? It will output, actually right here, turns output on, and this will output 200 milliamps. So when pin 2 is less than 1/3 VCC, you will find an output of 200 milliamps at about 1/2 VCC on pin 3. Pin 4 is our reset pin. If you want the chip to work, you need to tie this pin high. Simplest way to do that, connect pin 4 to pin 8. Now, if you anticipate needing to reset the chip, don't do that. But in the general sort of things, that's the way we do it. Next, pin 5, the most misunderstood pin on the 555 timer, and I myself don't understand it fully as well. But pin 5 is called your control pin or control voltage. And what it does is it controls the timing of the output independently of any RC circuit. C-U-I-T. There we go. Any circuit. So you know how we set up a 5.5 timer with 2 resistors between pins 7 and 6. You connect 6 to 2, and then you put a capacitor down here and make our little RC circuit. Well, when you output a voltage into the control voltage pin, it has to be above, greater than 2/3 VCC. What will happen is it will add something to the timing. It will change the timing. But in most cases, you just put a 0.1 microfarad to ground because you just don't use it. All right. Pin 6. We're about to come down here. Got kind of out of the way up there. Pin 6 is our threshold. Just remember this. 6 is the opposite of 2. So 2 turns on our output when we are greater than 1/3 VCC. 6 turns off the output when it is greater than 2/3 VCC. This is the other way. This is supposed to be less than 1/3, greater than 2/3. Yeah, that's the way that goes. So it is the opposite of that. Now, pin 7 is our discharge pin. And its job is simply, when the output is low, it discharges our capacitor to ground. That's it. That's all it does. That is our timing capacitor, of course. Discharge, we'll put that in here. Our timing cap to ground. And pin 8 is VCC, or our supply voltage. So, having watched this, do you now understand why this circuit works? Take a look here. I'll pull this out for right now. Oh, look at that, huh? So here's our 555 timer. Pin 8 goes to VCC. Pin 1 goes to ground. Pin 4 goes to VCC. Nothing else is really connected here. Pin 6 threshold connected to pin 2 trigger. There's our output going to an LED. So I'm just connecting this, our threshold and our trigger at the same time, to this little switch over here. And if you look at the switch, you can see one side is connected to ground, one side is connected to VCC. So right now it is connected to VCC. So we are getting higher than 1/3 VCC. So nothing's happening. Now we switch it this way, and our trigger is connected to ground, which is lower than the VCC, and it turns on. And of course the opposite happens on pin 7. What do you think? Does that make any sense to you? The 555 is my favorite IC. I know a great deal about it, but it's hard to come up with ideas to explain some of the subtleties of it without going too far into the weeds, and then people are just like, oh, what the hell are you talking about? Well, don't worry, I don't know what I'm talking about sometimes either. But I hope that explains how by toggling these 2 pins, we turn this one on and off. You can do it in so many different ways. So I think what we're going to do next is we're going to go through monostable, bistable, and the astable modes of the 555 timer. So we'll add them in as well as we go along. But I hope you enjoyed this little video on the intricacies of the 555 timer. And if you did, I hope that you'll give me a thumbs up. Feel free to comment, share. Don't forget to subscribe. And that's it. I'm out. Peace.